Tell me something. There is a Cristiano Ronaldo challenge on Instagram and TikTok where a football or a soccer ball is suspended in the air and you're supposed to jump and head it. I have been thinking about taking it, but then for a variety of reasons I have not been able to do so. Your research, from what I understand from it, I have actually done a favor to myself. Is that right?
That's very interesting. I didn't even hear about this challenge.
Oh, there is one which is going on. They just hang the ball in the air and then you're supposed to jump because he has the record of jumping the highest and heading the ball. And so if you do it, you get some goodies as a prize. Yes.
Yeah. Very interesting.
Yeah.
Yeah. So I guess what we found is through our experiment, even the very mild soccer headers that happen on the field, maybe like a hand thrown in type heading, could cause the brain waves to slow down for a brief moment before recovering. And so while from the experiments it didn't seem like there were any long-lasting effects from a few headers, but still it for the first time has shown that even a mild header can have some measurable effects on the brain.
It slows down the brain. Is that true? That's what I understand. At least that's what the news bite said, which was circulated by the university. Yes.
Yeah, so what we measured were brainwaves, and we typically make these measurements during things like sleep or epileptic seizures, and we would observe changes in brainwave activity. And so there are different types of waves, and some are faster and some are slower. And usually when we're alert and thinking a lot about complex problems, the faster brainwaves dominate. And when we are asleep, actually when we're in deep sleep, we see these high amplitude, slower waves that appear in the brain. And so what we found was that immediately after a heading event, we see that the brain waves kind of dominate in that slower wave component. And so it seems to imply that the brain waves are slowing down right after the header, but it would recover shortly after.
Which groups are vulnerable? Are adults at greater risk, or is it kids that are more vulnerable than the rest? In your study, what did you find out?
Yeah, we would think that for kids, because their brains are still developing, we need to be a lot more careful about subjecting the developing brain to any sort of forces that are exceeding the normal levels that we experience in everyday life. So even though there hasn't been a whole lot of research, also because it's very difficult to make measurements in kids, but I think we should caution against kids having high levels of exposure to head impacts, and that includes heading.
You have said that these are momentary changes. Are there any long-term impacts of heading the ball?
Yeah, just from our experiments, we only simulated the very mild header types and not too many of them during each of the experiments. And so we didn't measure any long-lasting changes in the brain from just a single session of heading. But there are also studies that have been looking at longer-term, potential longer-term changes in the brain. And different studies kind of have shown different results. There are studies that may have shown that in advanced brain imaging, there are some changes that we observe in the longer term with repeated exposure. There are also other studies that have not found significant changes in the brain. So I think in general, we need to have a better estimate of how many headers, how many head impacts each player, each athlete is actually sustaining to have a better understanding of their exposure level. And then we also need to do more of these longer-term studies to track how the brain might change over time.
Because football is not understood to be a high-contact sport like, let's say, American football or rugby or something like that, or even ice hockey. So this is should people be scared about what you've just found?
I would say what we found the good news is that we don't have to be too alarmed about a single header because the change is momentary, or a single session of mild headers.
Okay.
But we should have the awareness that the brain can still experience something even after these mild head impacts. So one thing that would be good to watch for is any sort of concussion-like symptoms after a header event or after sustaining a few headers. If there are any symptoms like dizziness, headache, etc., then one should just be more cautious to get it checked up. And besides that, I would say we should be limiting the total exposure and the frequency of exposure to headers and other types of sports head impacts, because it's very likely that as the impacts get higher severity, a higher amount of forces involved, and also if they become more frequent, like multiple high severity impacts are sustained during a game, for example, then that might start to cause some more obvious effects.
Right. But what you're suggesting can radically change how the game is played. Because heading is an important part of soccer, at least it is understood to be one. And the way, as I said, Cristiano Ronaldo challenged, and there are many other players. Diego Maradona used to, for instance, head the ball and keep heading the ball, and he used to show it as a trick before matches. So all of that would change, given what you're suggesting.
Yeah, so I would say from the injury risk standpoint, I would say even though it's a really cool trick to be able to use one's head to redirect the ball and have really high accuracy and where you're aiming and have a good amount of force going into it, but at the same time, our head is also experiencing that force it's not used to taking. And so in that case, in general, if it were up to me, I would say let's try to use other techniques, and protect our head. At the same time, something really mild, one also shouldn't be too worried about it, including parents of youth that are playing soccer. I would say we don't need to worry too much about it based on our research, but at the same time, it's probably a good idea to consider using the chest to take a ball or using the foot to redirect a ball. Yeah.
Yeah. So did you contact any teams or any team management when you're doing your research? Are you anticipating that teams might reach out to you? Because it is a multi-million-dollar sport. And as I said, Ronaldo, and there are so many other star players who are liked because they can head the ball in a certain way. So all that would change, and then this industry might take a hit. Are you anticipating any kind of feedback from there? And there's also the possibility that there'll be other researchers that will try and say that, well, don't be too alarmed. This doesn't happen because the way it has happened with other industries, the liquor industry. Sorry, I may be stretching it a bit too far, but it just occurred to me that it might still be possible because this is a multi-million-dollar sport.
Yeah, absolutely. I would say our research is also just kind of at the beginning of trying to investigate the effects of individual headers. And we do also need more research data to then understand maybe the exact threshold for how much exposure is too much. But certainly in a lot of these sports, including American football and soccer, these are huge, gigantic sports that are being played by so many people across the world. And any changes are very hard to push. Right. And also, I would say the studies that are out there right now are showing different results. And so I think we need more research evidence before we can convince regulatory bodies to make any changes.
Dr. Lyndia Wu, thank you so much for your time and for sharing this. Before you go, I just had one last question. What are the future pathways that you are creating with your research? What are the other lines of investigation that you are likely to pursue after this?
So we have some other ongoing studies with ice hockey and also with rugby, where we are making on-field longitudinal measurements, including advanced brain imaging, so that we can start to understand that relationship between longer-term exposure and whether or not in the longer term the brain might be experiencing any changes. So that would be quite exciting for the lab.
Thank you so much, Dr. Wu, and it was lovely speaking with you, and may you find something nicer next time.
Thank you.
But thank you so much. It was really helpful that you came out with this research.